Hi, everyone. First off, thank you for coming. This is exciting. We get to talk about how technology is intersecting with agriculture, which is something that's very near and dear to me. As a fifth-generation farmer that grew up on a family farm in Michigan, don't hold that against me. We love Ohio, too. And went into the technology space. So I studied computer information systems and ended up really falling in love with technology and what it, sorry, I'll stick to the mic, what it can do. But I come from a farming background myself, and that was really the passion that inspired me to get involved in this space. And I get to do what I love every single day because of it. So we're going to spend some time today talking about how technology is enabling a new era of farming. And this is something that my company works on the intersection of. So a little background on that. We're a small independent technology company based here in the Midwest. We started in Silicon Valley. We have some investors in Silicon Valley, but we also decided that the Midwest is a place to build our business because this is the market that we serve. This is where our roots are. This is the community that we want to be a part of. And we're doing things like tapping into the universities that are here that are cutting edge in this area. And so we are a Midwest company, even though we are a venture-backed business focused on building internet technology. Interestingly enough, actually, Ohio State turns out to be an investor in FarmLogs through one of their investments in Drive Capital. So some of you may be familiar with them. They're a venture capital fund here. Drive is a partner to our business, and OSU has an investment in their fund. So why do we even exist? Well, growing up on the farm, I saw an opportunity to create a better future for farming and really believe that technology was going to play a key role in agriculture moving forward, and yet it wasn't happening fast enough, and I wanted to be a part of helping shape that and bring that to my family's farm. My dad, my brother, my uncle all farm. The whole community that I grew up around is farmers, and we saw a chance to help farmers start using data science and apply that into their businesses to make smarter and more controlled decisions. We can remotely monitor what's happening in the fields and actually help them react in season using data, which is very exciting. So we fully believe that agriculture is being revolutionized by technology today. We're in the midst of that, and I think many of you probably agree with that statement and have seen some of the very exciting things that are happening. It's not just us. There's lots of people in this space trying to bring better technology solutions into farming and really think about solving some of the problems that farmers are dealing with. We are not a company that sells inputs. We believe that's very important. So I mentioned earlier, we're an independent technology provider. That's something that the market, the customer base that we serve really values. So if there's any farmers in the room, I bet you understand what I mean by that. You want to be able to trust that the advice you're getting, the agronomic advice, the data that you're getting is not biased, and it gives you the freedom and flexibility to control your business in any way that you see fit. So you can choose to work with whatever partners you want and still get the correct advice, scientifically speaking, about things like how much seed do I need to put in this field. Our business is not influenced by that, and we've built that into our business. It's a key part of who we are and how we serve the market, which has worked really well for us. It is one of the main drivers behind our growth. So even though we're a small company of just 60 people today, we actually have 20% of the farmland in the country, over 60 million acres of farmland being managed in our system. And this is organic growth where farmers have signed up for our product, they've downloaded it, and they've entered their land into FarmLogs to be able to get the value that we can offer them. So let's talk a little bit about what this actually means for the farmer. And the job of the farmer today is changing very rapidly, not just from a data perspective. I mean, I was talking with Dr. Shearer just before the presentation about how the machine is changing, and we were getting excited about Case's new fully autonomous tractor that doesn't have a cab. You can't even put a human in the machine. There are so many changes happening, and the farmer now has to deal with all these things and understand what it means for them. And we really believe that there are several different forces at work here where we're seeing advancements in compute technology, we're seeing mobile becoming something that is in every farmer's pocket. A computer that can actually bring them new information to help them run their business. They have it with them. We're seeing advancements in artificial intelligence. All these different things are working together, and we really believe that at the center of that, the cloud can actually power new innovation. It can help provide the infrastructure and the resources that allow a small company like ours to go and serve over 100,000 farmers. We can deliver really great capabilities to a grower very effectively without having to have our own data centers. So what does that mean for farmers? Well, it's changing really, really quickly. The cloud also enables us to reach people incredibly fast. Because they already have smartphones, they already have computers, we can now actually get this technology into their farms very quickly. And so the software of the past is going away. This is the old way of doing things where you're only able to analyze the data that you have on your own computer, that you have access to. It's slow, it's cumbersome, but the way of the future is having something simple and beautiful right in your pocket, where the information is coming from all sorts of sources that can be stored and provisioned on the cloud and then delivered into a beautiful, easy-to-use mobile interface for the grower. And what that means is that the future of farming technology is actually being built on the cloud. So because of the topic of this conference, I wanted to spend a few minutes actually talking about what that looks like at FarmLogs. So our company actually does host all of our services on Amazon Web Services, and we're doing things that are really interesting. So this is the workflow of building FarmLogs product in the software. One of our developers can write code at the bottom, and they don't have to think about what's going on behind the scenes on the infrastructure. They're able to write the software, and then they provision it out to GitHub, which is just a developer tool that helps store source code. And that's all they need to worry about. From there, we've actually built a service that uses Jenkins, which is a deployment automation tool, and it tells this little custom server that we built that controls a Kubernetes cluster, which is just a server orchestration technology, that there's new code that needs to be provisioned. And so we've got this application that's serving hundreds of thousands of farms. It's got many, many terabytes of data that's being served up, and we need to be able to get a new version of our software out to our customers quickly. We want to deploy a new app. As a developer, I push that code. Jenkins detects that. It tells Kubernetes, hey, we've got a new version of our application that needs to go out onto our cloud infrastructure. And then underneath of that is AWS infrastructure. So we have servers that can scale horizontally, adding new compute resources as we need them. We have RDS instances with databases that are storing all of the data that's being analyzed and processed in FarmLogs in S3 buckets that can store files. So we can actually do automated code deployments in a way that's highly sophisticated. It allows us to actually not have to think about the infrastructure behind the scenes, but programmatically control that in a way that actually allows us to serve our customers better, because we have to spend less time worrying about the technology behind the scenes and more time actually solving their problems and innovating for them. So I want to talk a little bit about these actual data sets that we're putting on AWS and what they actually look like. And so just as a visual, we are actually able to make heavy use of satellite imagery today. This is incredibly exciting for growers. We did not have the kind of information that is available today even just a decade ago. So in 2009, there was a company called Blackbridge that put up a constellation of satellites that is one of a kind. It is able to monitor the Earth every 5.5 days at a 5-meter resolution, capturing not just the visible spectrum that our eyes can see, but also the red edge and the infrared, which allows us to actually analyze how healthy plants are in a given area at a resolution that's the size of this stage. So instead of public data that is 30 meters, we now also have the capability to go down to sub-field management, where we don't have to just look at large regional analysis. We can actually measure within the field thousands of samples within a single field and start computing how productive is that area. And then we can combine that with things like weather and soil data sets that allow us to go further, and we'll get into detail on there. This is 47 terabytes of data that is being stored in S3 on Amazon. We can very easily just download it into the S3 bucket, and then we're able to organize that in a way that's easy for our software to query and analyze. This is the area that we're covering, so it's pretty massive. Just about anywhere where we're growing corn here in the United States, we have imagery for. So this is information that we've already analyzed and we'll be able to look at the past 6 growing seasons, every single image that satellite captured every week as it was flying over that field. We've already been able to pre-compute and analyze all of that and create our own new proprietary data sets and models that allow us to understand what has been happening in that field. So for a grower, think about that. You don't actually have to bring in data from machines like you used to get value out of precision ag technology. You can sign up for FarmLogs, and before you even got there, we already had 6 years of history of how those plants have been performing in your field, no matter where you're at, no matter where you're growing corn. So just to kind of show what that looks like, for those of you that maybe aren't as close to agriculture or haven't really worked with remote sensing data before, this is a field before it's planted. So you're not really seeing anything too interesting. This is an early season image where we were capturing it back in May before we planted the field. And there's not a lot of real variability. The image is all pretty static. It's just measuring the soil. From the scientific side, there's some interesting things you can do to measure bare soil and actually understand some of the soil properties and characteristics. But right here, we're trying to analyze how healthy the plants are. So nothing too special there. But then later in the year, we see the crop actually starting to grow. And you'll start to see a little bit of variability in some of the trends and how the plants are now reacting to the environment that they're in. We're starting to measure the reflectivity of the plant, not just the reflectivity of the soil. Later in the year, you'll see that fill out. As the canopy is developing, it's closing in, and now we're measuring more biomass. We're actually seeing more of the plants filling in. And then later in the year, when you've got a full canopy, you can actually start to see some really interesting patterns. And a lot of these can be predictive of yield. At particular stages of growth, you can actually start to understand how the plant is developing and what the relative yield distribution is going to look like on this field. And so you can actually see in this image, hopefully you can see it, it's kind of washing out a little bit, but there's 2 different hybrids of corn planted in this field, and we can see the line in the middle where it splits the field, where you can see that one is actually behaving differently than the other. And then there's some patterns, some vertical streaking in there. That's equipment issues that you can actually deal with. Yeah, question? This is WDRVI in this particular example, which is a wide dynamic range vegetative index. It is similar to NDVI, but it's specifically tuned for working with plants like corn. Works a little better for us to pull out more of the variation. And we use several different vegetative indices. So we actually have all the raw data that we can then go and compute these different indices for different purposes on a field. Yep, so this is satellite imagery that is being captured at 5-meter resolution on a weekly basis throughout the growing season. So we actually have access to that archive for every single image that's been captured looking back all the way to 2009 on a weekly basis. So it's a lot of data, it's a lot of imagery, a lot of measurements of how the plants have been performing in the field. And it's really exciting because that didn't exist before. You know, we've had monitoring programs with Landsat for a long time, but you're talking about 30-meter resolution data. This is 5-meter resolution data where you're actually able to now go sub-field and really quantify the variability in the fields. And so we're able to then tell the story of how that whole crop was produced and what it looked like, and we're able to analyze it for the grower, which gives them the option to start actually reacting in season. We've developed a technology that is pretty unique where we help farmers deal with scouting their fields. So instead of having to go to fields and hopefully see something from the road or maybe walk out, you get a different perspective from the satellite. You can actually see every 5 meters of that field. And then, it actually saves time in figuring out where do I need to actually pay attention? Where is there something unique happening in the season? We can actually look at all that historical information of a field, know what a normal performance looks like on that specific field, and then highlight any abnormalities. So we can actually detect anomalies that are in the season where the crop isn't as healthy as it normally would be at that spot in that field. And we can highlight those for the grower where they just get an alert that looks like this. It actually shows them the map of where exactly in the field. They can even get a notification. This is my smartwatch, where so I'm getting an alert about an issue in our field, and then I get a map that shows me exactly where it's at, and I can now go scout more effectively. And in this particular case, I saw this, I showed this to my dad, and he had just been to the field the day before, and from the road you actually couldn't see the damage to the crop, but this was a nitrogen deficiency where we had some lighter soils and there was a lot of leaching that year because a lot of heavier rain than normal. And so our monitoring service was able to pick that up, and I actually got to the field and I saw great looking corn from the road, but I actually used the GPS on my phone to now walk out in past the first few rows that looked healthy and got out to this spot that it showed me. And sure enough, the problem was there. So, even farmers that have been doing this all their life, like my dad, who's a great farmer, are able to find ways to use technology to improve what they're actually doing and find new information that they didn't have access to before. And we've simplified that for them. Here's one other example where a customer of ours down in Texas actually was scouting his fields. He had heard from neighbors that they were dealing with grasshopper problems, and it turns out that the wind was coming from the northwest, and they were scouting all their fields on the northwest side because they assumed that's where the problems would be if they had any grasshopper problems, because the grasshoppers were from up in the northwest. The wind was coming down that direction. But this alert came in, and it happened to be on the southeast corner, the opposite end of where they had been scouting. So he went back out to the field, and he scouted, and he discovered they did indeed have a grasshopper infestation that they were able to go out and spray for and fix that problem in season before it caused more yield damage. Really exciting use cases of data in agriculture actually making an impact. So that's how you can use this data in the season to react, but you can also use this imagery to plan for the future. So in precision agriculture, what we want to do is we want to actually control for the environment. So instead of just applying the same amount of seed and the same amount of fertilizer to the whole field, why wouldn't we want to dial that in specifically to what the environment can make the most use out of, maximize our return on investment, put more seeds where the soil can support a higher population, put less where it can't, put more nitrogen where you're going to get a bigger payback, put less nitrogen where you're not. So in order to do that, you have to understand the variability that exists in the field. And imagery presents this whole new opportunity, like we talked about before, to look at all those different seasons on a field at higher resolution than a yield map, with more measurements per year than a yield map, and actually understand, combined with all these other data sets like soil and precipitation, how that plant developed and how it reacted to the environment it was in. And so we can actually start to calculate some of the variability that exists in the field for the grower, look at the field throughout all the different growth stages, and then be able to predict what the yield distribution is looking like on that field. And that helps us build what's called management zones for a field, where you can actually start controlling your management, controlling your seeding rate, controlling your nutrient rates in the field at a much more precise level. So we did a comparison, of course. We did some research. We have a science team that does this, and what you're seeing here is one of our yield proxy maps where we predicted the yield on this field and the distribution of it versus the yield map that came from the machine, the combine. And if you look at those, they're pretty close. It's pretty incredible how many of the patterns are being detected, and I would argue for several reasons that actually imagery is more precise and more accurate in yield prediction than even a combine monitor can be. So that gives us the ability to create these zones that really help the farmer, and then you're able to take that data, all that new data about how the environment what environment you're dealing with, and you're able to combine it with all this knowledge we built up about how nutrients work and how they will react in that environment, which is incredible. So we know so much. We, as in the agronomy community, not just FarmLogs, but scientifically, there's so much information on how nitrogen reacts, so many studies that have been done that we can actually take that science and we can now embed it into software combined with all this data about the environment. So you don't have to wait 10 years to study and measure. We have the measurements, and we can then package that into software that allows the grower to make use of it right away. So what you have are all these different forces at work that are enabling this revolution in agriculture. You've got better access to data. You've got cheaper resources to compute where you can do this at large scale. You've got the mobile internet to help distribute it out to growers and actual precision equipment out on the farm. So those things combined into allow us to create technology that's very easy for a grower to adopt and actually apply on their farms. And it's part of what shapes our thinking about what agriculture will look like in the future. So taking these things, all these new data sets, combining them with the true agronomy and building crop modeling that can help us predict how the plant is going to respond to the environment, and then actually delivering that in software that ends up being a recommendation for the farmer. Very exciting times for growers. And so here's what it looks like in FarmLogs. We're creating a variable rate prescription. You've never seen anything like this. There's not any technology that's this easy to use on the market besides FarmLogs. So in the past, you had to use that geospatial software to do all the analysis yourself and figure out where the higher performing areas of my field were the lower performing areas. We're inspecting it. We can see the different seeding rates that are being distributed across the field. I save that prescription, and then I click share or download, and I can generate that prescription in the proprietary format that you need to integrate into any of the equipment on the market today. So you just saw it. That was about a 30-second process. That's an actual screen recording of me using the FarmLogs app to create a variable rate recommendation for that field. There was no other work necessary other than selecting the field that I wanted to create that for. And so that opens whole new doors for the farmer to be able to do something like that so simply. What excites us the most about this is that we're solving real world problems. There are a lot of other technology companies out there that get to work on things like, making it easier to share photos and building new messaging apps. But this is a space where we can really make an impact on the world. We have a chance to use the knowledge that our community has, use the skills that our team has, and deliver it to the grower in a way that solves real problems that our world is facing. And it's everything from helping them adjust their inputs to get better profit off of their fields. We're not getting any more farmland, right? We actually, I believe, lose farmland every single year, and yet food production needs to increase. And so how are we going to do that? We have to make better uses of the resources that we have. So FarmLogs is enabling growers to do that through variable rate farming. We're using satellite imagery now to detect problems in the field and help them react to them in the season. Nitrogen monitoring to help them see if their crop is going to come up short or if they need more, if it's a good investment to put more nitrogen down. So instead of just guessing and hoping that you're going to have enough to get through the whole season or over-applying to protect yourself, we can actually help cut back on nitrogen and be better stewards of the environment. And then we help them really tie that all together in an easy way that allows them to execute a successful farming plan. You can come up with the best plan you want at the beginning of the season, but you can't predict the weather. And so things are going to need to change, and you need to be able to react to that. And what we're doing is empowering the farmer to actually adapt their plan throughout the season and still make it a profitable operation that's good for the environment. And it's working. So, in this instance, Corey was able to add an additional $68 of profit through both increasing his yield output by about 15 bushels and then also decreasing his nitrogen usage by timing it right and putting the right amount in to where it's actually going to deliver a payback. In this case, Clint was able to detect a equipment pattern where he was working with a custom sprayer, and they were flying on nitrogen, and they were making passes that were too wide, and he didn't know that. But because it didn't show up on the yield map, because the yield map's too wide, and the strip wasn't visible on his yield map, it just gets smoothed out by a combine. But he looked at our imagery, and he saw those strips, he saw those passes where they were applying too wide, and he was able to fix it. He was able to work with that custom applicator to show them the problem, and they tightened their passes up. And now he's saving $16,000 a year. We're in a new era of farming, and it's becoming digital, and it's a very exciting time. Thank you. Do we have time for just one or two questions? Yeah? Yeah. So I'll repeat the question. He said, Rapid Eye is getting old, so what are we doing to keep up? Well, first of all, Rapid Eye is still the only fully operational constellation that can collect this scale of data at this resolution, and it's awesome. You know, as a grower, to get 6 or 7 images throughout a growing season of your field is pretty powerful. But you're right, there is huge new opportunity in new data sources, and you know, we've bet pretty heavily on satellite because we believe that today the infrastructure is there. We can deliver these solutions now. We don't have to wait. The logistics of flying UAVs is complicated and it's very expensive. I mean, I challenge you to find a grower that's actually using it as a business tool to monitor their crops all season long. It's a lot of work. Why not use them once you've found a problem through satellite imagery to go out and scout for you? Until we can fully automate that, you know, the drone being able to fly itself without a farmer needing to go to the field. But to keep up, there is new opportunity in satellite. So the Rapid Eye constellation was purchased by a company called Planet Labs. They've since rebranded as Planet. They are launching a daily imaging capable constellation at 2 to 3 meter resolution. So we have access to that constellation today. We're one of their biggest customers, and so we've been doing R&D work on their new, not operational constellation, and they plan to be fully operational and commercialized for next year, where they will be able to image the entire globe once a day at 3 meter resolution with the infrared band as well. So it's exciting. We're already investing in the capability to expand our coverage frequency with them. Mm-hmm. Yep. So what we try to do, he asked about what predictive models we have. So what we're trying to do is understand how the field typically performs, and things like nitrogen are really important to the farmer. So when you're growing a corn crop, outside of weather, that's the single biggest factor that you can control that's going to have a big impact on, you know, your yield at the end of the year. And so we're actually able to predict how weather is driving nitrogen volatility. So you can lose nitrogen to many different forms, and there's crop models that can help predict that based on the soil texture and type, the hydrological properties, the organic matter that's available there. So we have all that data about the field already, and then what we're doing for the farmer is watching how the weather is developing throughout the season and predicting how much nitrogen has been taken up by the plant and how much is still available to the plant to reach its yield potential. And when there's a shortfall of nitrogen, we can actually predict that and tell them that they're going to need more. We don't try to predict the weather long range because we don't believe that that's very possible today at this hyper-local, precise level. But we can measure the weather, and we can use that to predict how much nitrogen is still available. Yep. One more question? Yeah. So the question is, are we dealing only with corn growers or other types of farmers as well? And the answer is we actually work primarily on row crop agriculture. So everything that you're seeing grown here in the Midwest, corn, soybeans, wheat, are the 3 major commodities, and then alfalfa and smaller grains and dry beans, sugar beets, all those kinds of crops are being managed in FarmLogs today. The only things we don't really work on are like permanent agriculture, you know, vineyards, orchards, the stuff that you're going to find mostly out west. But here in the Midwest, yeah, we are working with growers that are raising all kinds of crops. Do we have time for one more? We got. Oh, yep. So the question is, what soil information are we using? Well, the USDA has a data set called Surgo that is available very broadly, and that's a starting place for us. It's going to help us understand what basic soil textures exist in a field. It's not very precise, so you would never want to use that for precision ag management because it doesn't capture the real variation in the field. And so we combine that soil data with our satellite imagery and bare soil analysis to be able to understand more specific information about the soil that we're dealing with. And in the future, there's lots of ways to expand that into testing, which is tricky to get right scientifically, and you know, all sorts of other data sets, like even electroconductivity, to figure out where you're seeing different organic matter percentages throughout the field. So with that, I think we need to wrap up. Thank you, everyone.